In section 8.1, we're going to be talking about tangent lines to circles. So basically what a tangent line is it's a line that intersects a circle at exactly one point. And we call that point the point of tangency. That's going to lead us into our first theorem. So if a line is tangent to a circle, then the line is perpendicular to the radius at its point of tangency. So if I draw my radius to that point of tangency, that's always going to be a right angle. And that's going to be the key to being able to solve a couple of different algebraic problems that we're going to see next. So let's say in example problem number 1, I want to solve for x. So here we can see that x is a missing angle measure. I see here that I have a triangle. I know that all the angles in a triangle add up to 180. I can see here that this is a tangent line. So I have two angles. To find the missing one, I'm going to do 180 minus 38 minus 90. And I see that x would be 53 degrees. I also could work with problems dealing with side lengths, and I'm going to show you an example here that'll be a little bit longer. They all won't necessarily take this many steps, but this is probably on the more challenging side that you would see. Here I want to solve for x. I'm given that this is a point of tangency, so I know that this is a right angle. Whenever I want to find a missing side length in a right triangle, I'm going to use the Pythagorean theorem, which remember is leg squared plus leg squared equals hypotenuse squared. So my legs here are x and 12. So I'll do x squared plus 12 squared equals, I see that my hypotenuse is broken into x and then 8. So I'm going to write that as x plus 8 squared. So to solve this, what I'm going to want to do is, well, first on the other side, I could do x plus 144, that's 12 squared. And I'm going to write out x plus 8 squared in both of its terms, so x plus 8 times x plus 8. Here, I could see that I would want to FOIL to get rid of the parentheses, and I'm left with this expression. Now, what's nice about this problem is that the x squareds are going to cancel on both sides, which will make this a lot easier to solve. It's not going to happen every time. We might look at a problem like that in class. I'm going to cancel out those x squareds. Now I'm left with a pretty basic Algebra 1 problem. In 2 steps, I can get x by itself. I'm going to subtract the 64 on both sides. And then finally, I'm going to divide by 16. And I have that x equals 5 after all that work. And now in problem number 3, another kind of question that you could get asked here is, let's say I have this diagram and I'm asking you, is LM tangent to circle N at point L? So here I'm not told that this is a tangent line. I want to determine if it is. And this theorem works both ways. So if I have a tangent line, then I know that I have a right angle. If I see that I have a right angle, I can assume that it's a tangent line. So here, basically what I'm being asked to find here is, does the Pythagorean theorem hold up in this triangle that I see? If the Pythagorean theorem holds up, then I know that that's got to be a right angle for angle LM, and then I'd be good to go. So I'm going to check to see, does 7 squared plus 24 squared equal 25 squared? They do, so I'm good to go. Last thing we're going to learn about, or the last theorem in this video, if BA and BC are tangent to point O, so if I have two lines with going to the same point outside the circle, and if I draw them to make tangent lines, then those lines would be equal to each other. And that's going to help us solve the last kind of question that we're going to look at. Let's say I have this whole diagram here. I'm telling you that circle O is inscribed in triangle ABC. What inscribed means is that basically I'm drawing that circle inside the triangle, and that circle is touching that triangle all at one point. So I can assume that AB, CB, and AC are all tangent lines. Given that information, I want to find the perimeter of ABC. So, knowing that if I have two lines drawn from the same point outside the circle, and they're both tangent lines, I know that they're equal to each other. So if DB is 15 centimeters, BE would also be 15 centimeters. If FC is 8 centimeters, then CE would also be 8 centimeters. Finally, if AD is 10 centimeters, then AF should also be 10 centimeters. Now, I have all of my side lengths, so I can add up everything to find the perimeter. Remember, the perimeter is all the sides added up. So I would do 10 plus 10 plus 15 plus 15 plus 8 plus 8, and I would get 66, and I'd be done.